The logic of actuality is a branch of modal logic that studies the logical behavior of the concept actually. In ordinary language, we often distinguish between what is merely possible and what is actually the case. The logic of actuality introduces a formal operator, often written as at or sometimes as a, to represent statements of the form actually b. Thus, if b is a formula, the expression at b can be read as b is actually the case. This allows us to distinguish between sentences that are true at some possible world and sentences that are true in the actual world. The logic of actuality therefore refines standard modal logic by adding tools for reasoning explicitly about the actual world. The main motivation for developing a logic of actuality arises from philosophical discussions about modality and possible worlds. In modal logic, we often evaluate statements relative to different possible worlds. However, many philosophical arguments require distinguishing the actual world from merely possible ones. For example, statements such as, actually things could have been different, or something could have been true but is not actually true, are common in philosophical reasoning. Without a special operator for actuality, standard modal logic cannot easily capture these distinctions. The logic of actuality also plays a role in metaphysics and the philosophy of language, where philosophers analyze the semantics of modal expressions, indexicals, and rigid designators. Introducing an actuality operator makes it possible to formalize claims about what is true in the real world as opposed to other possibilities. Consider the following sentence. It is possible that everyone who is in fact standing is not. Neither, it is possible that for all x, sx implies not sx, nor for all x, sx implies it is possible that not sx seem to capture the meaning of this sentence. In a quantified modal system with an actuality operator, this sentence can be symbolized in the following way. It is possible that for all x, it is actually the case that sx implies not sx. The syntax of the logic of actuality usually extends the language of propositional modal logic. Formulas are built from propositional variables using the familiar logical connectives, negation, conjunction, etc. In addition, the language includes the modal operators, the box, necessarily, and the diamond, possibly. To this language, we add an actuality operator, commonly written as at. If b is a formula, then at b is also a formula interpreted as b is actually true. Apart from this additional operator, the syntax is typically similar to that of ordinary modal logic. The main differences arise in the semantics and in the axioms or rules of inferences governing the new operator. Some systems introduce a second one-place sentence operator, cross. If A is a formula, then cross A is a formula. Roughly speaking, cross A says the same thing as A, except that subsequent occurrences of at in A pick out the world that was the current world of evaluation when cross was encountered. The standard semantics for the logic of actuality extends possible world semantics. In ordinary modal logic, formulas are evaluated at different possible worlds connected by an accessibility relation. In the simplest version of the logic of actuality, a model includes a distinguished world representing the actual world. The truth condition for the actuality operator can then be stated informally as follows. A formula at B is true at any world if, and only if, B is true at the designated actual world. This means that the operator at allows us to look back to the actual world even when evaluating formulas at other possible worlds. In effect, the actual world functions as a fixed reference point within the model. Another approach introduces the idea of relative actuality. Instead of assuming that there is a single privileged world that is absolutely actual, this approach treats actuality as relative to a perspective or evaluation point. On this view, when we evaluate a formula at a particular world, that world counts as actual relative to itself. The operator at, therefore, shifts evaluation back to the world that serves as the reference point for the current context. This makes the semantics more flexible and closer to the way indexical expressions work in natural language. This can be done in at least two ways. Call a model a variant of a given model if it differs only in the world that is selected as the actual world. If W is the actual world of a variant of a model M, we can speak of the W variant of M. Then we can define the truth conditions for a sentence of the form cross A in the following way. Cross A is true at the world W in the model M if and only if A is true at W in the W variant of M. Some introduce a two-dimensional semantics. According to this view, the valuation function assigns truth values to formulas relative to pairs of possible worlds rather than to single worlds. We can say that a sentence A is true at a world W2 when the world W1 is treated as the actual world. Then we can define the truth conditions for sentences of the forms at B and cross A in the following way. At B is true at W2 when W1 is treated as actual if and only if B is true at W1 when W1 is treated as actual. And cross A is true at W2 when W1 is treated as actual if and only if A is true at W2 when W2 is treated as actual. Roughly speaking, cross A says that we should forget about the old reference world and let the new reference world be the current world of evaluation. Both approaches, distinguished actual worlds and relative actuality, have been widely studied in modal logic and philosophical semantics. Logical consequence in the logic of actuality is defined in a way similar to other modal logics. A formula is valid if and only if it is true at every world in every model that satisfies the semantic rules of the system. Because the actuality operator refers to a special world or reference point, the definition of validity must take this structure into account. Nevertheless, the general idea remains the same. A valid formula is one that cannot be false under any admissible interpretation. Several proof methods are used for the logic of actuality. Many systems employ Hilbert-style axiomatizations, where axioms governing the modal and actuality operators are combined with rules such as modus ponens and necessitation. Other proof systems include sequent calculi and tableau methods, which are often adapted from modal logic. In these systems, the special role of the actual world must be represented explicitly, for example by labeling worlds or marking the distinguished world. Such proof methods allow logicians to study which principles involving the actuality operator are derivable in different systems. The logic of actuality is often constructed as an extension of standard modal logic. Depending on which modal system is adopted, such as K, T, S4 or S5, the resulting logic of actuality can have different properties. Furthermore, the logic of actuality can be combined with other logical frameworks. For example, it can be extended with predicate logic, allowing quantification over individuals, or combined with temporal, epistemic, or deontic modal operators. These combinations allow richer formal analyses of philosophical concepts such as knowledge, obligation, and time, while preserving the ability to refer explicitly to the actual world. Many systems of the logic of actuality have well-studied metalogical properties. They are often sound and complete with respect to their intended semantics. Some systems also enjoy properties such as decidability and the finite model property, depending on the underlying modal logic on which they are based. Because the logic of actuality builds on modal logic, many proof-theoretic and model-theoretic techniques from modal logic can be adapted to analyze these systems. The logic of actuality enriches modal logic by introducing a formal way to talk about what is actually the case. By distinguishing the actual world from merely possible worlds, or by interpreting actuality relative to different perspectives, it provides a tool for analyzing modal reasoning, including reasoning about what is actually the case. As an extension of modal logic that can interact with many other logical systems, the logic of actuality continues to play an important role in philosophical logic and the study of modality.